All right, let's look at section. Hey, get out of here, you little ant. Let's look at some examples for section 5.2. And hopefully I won't get any phone calls this time or anything, and I can actually do this video. That'll be very exciting for me to actually be able to do that. So let's look at a couple examples of integrals, and these should be almost a little familiar to you from last year. When we were in pre-calculus, we did a few like this. So come along with me on this journey here. So from -2 to 4, I want to find the integral of 3 dx. And this x here, and it should match the x in here if there is one, but there's not because it's a constant function. We call that a dummy variable. That variable will go away. We're just going to have a number at the end. So let's see. The function is 3, so let's try to visualize this a little bit. The function is 3, and we're going from -2 to 4, from -2 to 4, and the function is just at 3, and this is just a rectangle. So the area is the length times the width, or the height is 3, the width is 6. So 3 times 6 equals, let's see here, 18. So that is the area. That is the integral between -2 and 4 of the function 3 is 18. That's how I would say all of that stuff. Oh, where's my green? Oh, there it is. Good. Let me switch to green here now. Okay, let's look at another one. Number 2. Let's look from -3 to 1 of the absolute value of x, something a little more exciting here, and then dx. And those x's should match. So let's, if you don't remember, we can, let me see. So gonna clear out my calculator real quick. Okay, now what does absolute value of x look like? Well, let's see here. Absolute value, math num, there's absolute value of x. Okay, and let's look at the graph. Whoops, I did a table. Let's look at the graph. And if I zoom decimal, that will actually give me the correct aspect ratio on the screen. There we go. It should be a 45-degree angle. So from -3, from right here to 1. Okay, so let me draw this out here real quick. From -3 to 1, and a 45-degree angle there and there. And let's add these two triangles together. Okay, we have this area and this area here, and we're just going to add them up. So the area of this triangle, well, that's 1/2 base times height. The base is 3 and the height is 3. And 1/2 base times height here as well. 1/2, the base is 1 and the height is 1. Okay, well, this is 9/2. Right, this is 9/2, and this is 1/2. 9/2 plus 1/2, well, that's 10/2. That'll just give me 5. So the the integral from -3 to 1 of the absolute value of x dx is 5. With respect to x is 5. Okay, so another example, and we're still using just the old ideas of area, those old formulas that you've known and loved forever. So that's our second example. Let's look at another one. Number 3, from -1 to 4, the integer function. Okay, here's another function, and let's look at the integer function. That's number 5 under num. Whoops, there we go. The integer function of x. And let's see what that's going to look like here. There we go. So from -1 to 4. From -1 to 4. Now I'm actually going to, for the first time, do the integral on the calculator, and that'll help us to be able to draw this out. So let me go ahead. It's under Calc, and it's there, number 7. That's the integral of the function. And I'm warning you right now, even though it's there, I'm going to make you do some stuff without your calculator. We'll have calculator and no calculator sections on our evaluations on this section. So don't think that you can just use that, because you won't be able to always. So just keep that in mind. So we're going to go from -1 to 4. So it asks for the lower limit. That was the lower limit down there, -1. And the upper limit up to 4. Hit enter. And that is the area underneath the curve. Now I want to point out something, is that when the area under the is beneath the x-axis, when it's actually the area above the curve there? Well, that's flipped over. That's going to count as a -1. So we have 1, 2, 3, 4, 5, 6 blocks up here. Okay, the area of 6 up there, and this -1 down here. So 6 minus 1. So the calculator gets that value of 5. Calculator gets the value of 5. So let me go ahead and draw out what the calculator had there, just to just so I can have it, I guess. I want to have nice notes here. So it was this area there, and then it jumped down, and then it was here, and it was here. So it went 1, 2, 3 up. Okay, and it was all this area here. Okay, and so this was a -1. There's just a bunch of squares here. This was 6, so -1 plus 6 gave me 5. So it's just the point I wanted to get across to you is that when something is below the x-axis, it counts as a negative area. And I guess the graph will continue on up there. Let me draw another unit up there. Okay, so that is the integral between -1 and 4 of the greatest integer function is 5. Let's do one more example together. We'll call this example number 4. Okay, the integral between -1 and 1 of the function 1 plus the square root of 1 minus x squared. And this is something that you, dx at the end. And this is something that you must now recognize as a half circle, as the graph of that top half of the circle. So let's look first at this. If I just had square root of 1 minus x squared, if I just had that, it would be, let me see, 1, 1, and 1. Between -1 and 1, it would be that. Okay, just a circle with radius 1, center at the origin. Square root of 1 is 1. But then I'm adding 1 to it. I'm going to move it up 1. Okay, so my actual graph here, this is going to look like this. So instead of this point at -1, 0, that'll be at -1, 1. And this point here, instead of 0, 1, it'll be at 0, 2. And this point here, instead of 1, 0, it'll be at 1, 1. So I moved my half circle up 1. There we go. And so the area between -1 and 1 is what I want to find. So I want to find the area between -1 and 1. Okay, to do this, we're going to break it up into two different shapes. I have this half circle, and I have this rectangle here. Area of a circle is pi r squared. So the area of half of that is half of that. Okay, and then the area of this section down here, well, that's going to be 2. 2 times 1 is 2. The area of the rectangle is 2. The area of that guy right there. Okay, so the area of the whole thing together, well, the radius here is 1, so I've put in 1 for r. This is going to be pi over 2. So all of this together, it's going to be the area of the whole thing. I like to draw a little picture there. The area of the whole thing, the semicircle, and the area of the whole thing. I just ruined my drawing. The area of the whole thing, there we go, is 2 plus pi over 2. I guess you could combine that in some way. I don't think it'd be any more simple, though. The area is 2 plus pi over 2. If that looks like a silo. So those are your examples. Most of those are like those. Some of them are, well, anywho. Some of them are from different parts. Some of them just ask you to change between different forms. But go ahead. I think that should be the information you need, and we'll talk in class about what problems are due when. Like before, we'll play those by ear. So, yeah, peace from the past. What?